Hello viewers, now we discuss today another interesting results of the measure theory, and let's watch this video till the end without skipping. If E is a bounded measurable set, then show such that this is a bounded measurable set, then show that there is a set. This set is T and this T containing E, such that this nature of the T is countable intersection of open sets. This is very much important, with measure of T is equal to measure of E, and this T is a Borel set. So analyzing this fact, what happens there in this statement? First one is the nature of E is a bounded measurable set, and we have to show that there is a set. So we find a set T, and this T containing bounded measurable set. This is the main nature. And then we find this condition. Which constant and condition is? This condition is T is countable intersection of open sets with, we find measure of this T is equal to measure of E. We have to prove this result. Now let's watch what happens. At first, it is a given statement that given a natural number we take n. So here we find a natural number small n. Then we find a bounded open set. The set is Tn. We are finding here sequential format. As T is a Borel type of set, so we are taking in this measure like a sequential structures. So we are taking as Tn, and the result which containing E by this condition, given definition T contain E, that's why we taken this Tn, that Tn is containing E. Now satisfying measure of Tn less than measure of E plus 1 by n. This is a property of limiting cases in real analysis especially, and cases of infimum and supremum properties we are using as per our definition criteria. Obviously cases using these cases in real analysis. So m of Tn, measure of Tn less than measure of E plus 1 by n. And now we are setting here this type of T is Borel set. And what is the nature of T? Here is given T is countable intersection of open sets. So nature of T is countable intersection of open set. So we don't know where the countability ends. So we are assuming it as an infinite extent. We are finding this result as infinite extent. So we take T is equal to intersection of n equals to 1 to up to infinity. That's why this is the cases we find. So n equals to 1 to up to infinity intersection of Tn, and then T is included in Tn. T is included in Tn. That's why this intersection is included in Tn. That gives measure of T less than equals to measure of Tn, and that will be less than measure of T plus 1 by n from the earlier condition, satisfying condition we are using. And now taking as n tends to infinity, from this result, first one m of Tn is less than m of T plus 1 by n. As taking n tends to infinity, we find measure of T is less than equals to measure of n, taking it equation number 1. And again we are finding the using this condition of superset. From the given condition, T included T contains E, that T is superset of E, which gives measure of T less than equals to measure of E. So taking it equation number 2, and another one m of T less than equals to m of E, equation number 1. And from 1 and 2 we obtain measure of E, and measure of t is equal to measure of b. That means these two measures are equal, as we claim to our final conclusion and conditions. So finally, end our desired result, we end our discussion today. If you like this video, like it, share it, and don't forget to subscribe the channel. Thanks for watching.